All right, picking up where we left off. So now we're into multiplying and dividing radical expressions. We have to remember to rationalize denominators and get radicals out of the bottom. That's the key here with these. We will treat these like polynomials. So the best way is just to dive in. We got to be careful with our exponent rules throughout all of these. All right, so looking at example 1, square root of 13 minus 2 squared. We're going to treat this like we would a polynomial, right? We're going to multiply this out using distribution or FOIL, as some like to call it. So we're going to distribute this root 13. Root 13 times itself, it's going to give us 13, right? Because the square root of 13 squared is 13, okay? And then here's how we're going to write the next part. Minus 2 times the square root of 13. And then now let's do this part. And then last, we're going to have a plus 4. Now we will combine what we can. 13 plus 4 is going to give us 17. And then these two terms are going to be able to combine because we have the same radical, same index. And the 2's out front. This is going to become minus 4 root 13. Okay, root 13, remember this can be treated kind of like negative 2x minus 2x because these things are the same. The square root's the same, the indices are the same, and then the underneath the radical is just a 13. So this is what we end up with. All right, go ahead and try example 2. Hopefully you have ended up with something like this. 16 minus 4 root 5 plus 4 root 5 minus 5. All right, it's a minus because we end up with like minus square root of 5 squared, which becomes a negative here. All right, and then negative 4 root 5, negative, and plus 4 root 5, those are actually going to cancel out. So we really just end up with 11. All right, this example, this is the first time in a while that we have seen rationalizing denominators. So here's what's going to happen. All right, that square root goes to both the top and the bottom, but in math, we don't like that there's a 45 underneath a square in the denominator. Right? Somebody a long time ago decided, hey, let's keep our math more professional and get rid of radicals in the denominator. So what I'm going to do here, I'm going to see if I can simplify that square root of 45, and then maybe rewrite this denominator with smaller square roots, and then rationalize from there. All right, so 45, let's divide it by 5. And then we see quickly that we will be able to simplify that denominator. All right, it becomes 3 root 5. And then we still have that negative root 8 on the top. And then just for the fun of it, let's see, you know what, can we simplify that square root of 8 just for the practice? And you'll see that we can. Okay, so negative 2 root 2 over 3 root 5. What we want to do here is multiply by the radical in the denominator over itself. All right, that's what we want to do here. It's a version of 1. We're not changing the value at all of our expression. And what's going to happen is that the square root of 2 and the square root of 5, they have the same index, so the 2 and the 5 can be multiplied together to give us square root of 10. All right, and this negative 2 is still out front. And then now the square root of 5 can be multiplied together to give us 5, and then we still have this 3 out front. So we end up with negative 2 root 10 all over 15. That is fully simplified because the 2 and the 15 cannot be simplified. The 10 and the 15, you might want to divide them both by 5, but this 10 is protected by that square root, so it's going to stay right there. Okay, the only way we could simplify that, simplify that 10 is if we could break it into you know, a product of a prime number in a perfect square, which we cannot do. All right, example 4. Let's see what we can do. All right, square root of 200k to the 6th over square root of y to the 7th. So let's work with that 200 first. All right. I broke it up in my head as 10 and 20, and then 2 and 5. And then, let's see, 2 and 10, and then 2 and 5. And so what we're doing here is that 2 times 5 times 2 times 2 times 5, that's what multiplied together to give us 200. So we can see, oh, we have 2 2's here, and then we have two 5's here. So those can come out front as 2 times 5, and then this 2 is stuck inside the radical. Okay. All over square root of y to the 7th. Now let's look at those variables. Okay. So 2 times 5 will give us a 10. If we're trying to figure out this k to the 6th situation, this could be thought of, many different ways. One way to think about it is k to the 3rd squared, and then this can come out front as k to the 3rd. And then the square root of 2 is still stuck inside. Thinking about this y to the 7th, we can think about it like y to the 6th times y, right? And then this y to the 6th can be y to the 3rd to the 6th, which means a y to the 3rd is going to come out front. And then this y is stuck inside. Okay. We don't like that there's a square root in our denominator, so we're going to multiply by the square root of y over itself. And then we'll end up with the following. If I'm going too fast for you guys, pause the video, go back and see if you can make sense of what's happening. The best way to get familiar with these is just by going through a bunch of examples. All right. So now we have y to the 3rd root y times root y. All right, these are going to multiply together to give us y. So we end up with y to the 3rd times y, ending up with an overall solution. 10k to the 3rd root 2y all over y to the 4th. And you might be wondering, hey, can we simplify these y's at all? No, we cannot. Okay, this numerator is protected by that square root. So this y to the 4th is just going to stay right there. Okay, see if you can do number 5 on your own. Hopefully you ended up with the square root of 30 as your answer. If you didn't get that, all we're doing is multiplying by root 5 over root 5, meaning we have 5 root 30 over 5. Those 5's cancel, and we end up with root 30. Okay, number 6. This is one that is a very unique type of problem. Okay, so what we're going to do is we're going to rewrite this 16. We're going to rewrite this 16 as 4 squared. All right. And now we see, man, it would be great if this 4 was raised to the 3rd power, because then we could bring it out front and the square root would just be gone. Okay. So what we're going to do, it's kind of cool. All right. We need to multiply by something over itself. All right, and we need to make sure that the index of that root is still 3. Otherwise, we're not going to be able to multiply these together. And what we're going to put inside the radical is 4 to the power of whatever is going to allow this situation to be canceled out. All right, so we're going to multiply by 4 to the 1st. Because what that's going to do on the bottom is create the cubed root of 4 cubed, right? Because 4 squared plus, 4 squared times 4 to the 1st is 4 to the 3rd. Which means we just end up with 4 down here. All right, and then our numerator ends up with -3 cubed root of 4, and that's it. Those are kind of fun. Okay, these two require use of the conjugate. All right, so we're going to multiply. It's very similar to when we worked with complex numbers. All right, we're going to multiply by a form of 1, and the form of 1 we're going to choose to multiply by is going to keep the 2 and the root 3 the same, but we're going to change the sign to a plus. All right, so what we end up with here is that 4 times 2 plus root 3. Make sure you write in parentheses. And then now we have this conjugate multiplication situation, which I'm actually going to write out down here. Okay, 4 times 2 plus root 3 all over. Now we're using FOIL. 2 times 2 is 4, plus 2 root 3 minus 2 root 3 minus square root of 3 times itself just gives us 3. And this is why we use the conjugate, is because plus 2 root 3 minus 2 root 3, those cancel. So our radical's gone from the bottom. All right, distribute your 4 on the top. You end up with 8 plus 4 root 3. We can't multiply the 4 and the 3 together because this 4 is not underneath a radical. Over 4 minus 3 is 1. we just have 8 plus 4 root 3. Okay. Example 8, we're going to multiply by the conjugate again, all right? Conjugate is root 2 minus root 13. Careful with your multiplication. Okay, 7. So in parentheses. And then root 2 times root 2 gives us 2 minus root 26. All right, we're able to multiply the 2 and the 13 together because they're both under square roots. And then minus 13. Ending up with, let's see, 7 root 2 minus 7 root 13. Those 26's cancel, and then we end up with negative 11 on the bottom. I am fine if you leave it like that for me. Okay, example 9, kind of fun. We're going to try to simplify this radical. Okay, so looking at this, we're looking at, let's see, 2x over 6x, if we break it up, plus root 32x squared over 6x. So let's see if we can simplify this 32 at all. All right, 216, which you may know breaks into 4 and 4. Okay, so we're going to have, let's see, this 32 is a 4 root 2. And the square root of x squared is x, so that comes out of the radical. And that's still over 6x, 2x over 6x. The x's cancel out, okay? The 2 and the 6 will reduce to 1/3. And then almost done, let's see. The x's will cancel out again here. 4 and 6 will reduce to 2/3. So we end up with 1/3 plus 2 root 2 over 3, or you could even leave it like this because they're both over 3. All right, and our very last example, go ahead and give it a try. It's a conjugate example. All right, my work may look a little bit different than yours, but I'm going to do something that's going to allow us to simplify a bit quicker. All right, I'm going to change this to 8 times 2, and then I'm going to factor out an 8 down here. Okay, these are equivalent. I factored out an 8 from 24 and negative 8 root 5. Those 8's cancel, so what we're really trying to simplify is 2 over 3 minus root 5. Now we multiply by the conjugate, 3 plus root 5, and this is just going to allow us to get to the solution a bit more quickly. Okay, 2 times 3 plus root 5, and then as we're using FOIL with these bad boys, we end up with 9 minus 5, I believe, giving us 2 times 3 plus root 5 all over 4. And then I actually noticed that the 2 and the 4 can cancel out again. So we have 3 plus root 5 over 2. That's all I got. Try your practice. Just keep going and going and going. Do your best. Let me know what questions you have.